Today in this section, let us discuss about module 3, that is overview and channel structure of long-term evolution, that is LTE. Under this module, the topics we are going to discuss today is introduction to LTE. The main three parameters of LTE is design principles of LTE, network architecture, radio interface protocols. First, we will see the overview of radio interface. The radio interface of a wireless network is the interface between the mobile terminal and the base station. The 3G partnership project divides the whole LTE network into two networks, radio access network and a core network. In 3GPP, the evolved packet core, which focuses the core network evolution with a flat roll IP packet-based architecture. The complete packet system consisting of LTE and EPC is called the evolved packet system. The RAN architecture of UTRAN 3G and EUTRAN LTE are differentiated using the diagrammatic way. This is the overview of the LTE radio interface. Here we can see the architecture UTRAN as well as EUTRAN. If you see the UTRAN, it consists of RNC, node B along with the user equipment. But in EUTRAN, E node B and along with the user equipment. The main difference in architecture is EUTRAN 4G, that is E node B, is composed of RNC and node B of UTRAN 3G, and E node Bs are interconnected. The E node B supports additional features such as radio resource control, admission control, and mobility management. These three functions were originally performed in the RNC of UTRAN. This structure simplifies the network operation and allows for higher throughput and lower latency over the radio interface. This LTE was designed primarily for high-speed data services. So the high-speed data services can be achieved by packet switch network from end to end, and there is no support for circuit switch services. So what is packet switch services or packet switch network? So packet switch network is the communication network that groups and sends the data in the form of small packet. So to achieve the higher data services, LTE is working on packet data switch network. The next we'll discuss about design principles of LTE. Along with the specification or design principles of third generation, we have included as LTE specifications. The new LTE specifications are network architecture, data rate and latency, performance requirements, radio resource management, deployment scenario and coexistence with 3G, flexibility of spectrum and deployment, interoperability with 3G and 2G networks. Let us see one by one. Network architecture. LTE was designed to support purely packet switch traffic with support for various QoS classes of service. What do you mean by QoS of service? It is nothing but the quality of service is a way to manage multiple traffic profiles over a network by giving types of traffic priority. LTE is different by use of clean slate design and supports packet switching for high data rate services from the start. The LTE radio access network is designed to have minimum number of interfaces. The data rate and latency. Data rate is the design peak data rate target in LTE, and it is given as for downlink 100 megabits per second and uplink 50 megabits per second when operating at the 20 megahertz channel size. Latency. What do you mean by latency? It is nothing but delay, and whenever the single user equipment is present in the cell and the network is unloaded in the user plane, the latency is 5 milliseconds. For the control plane latency, the transition time from a camped state to an active state is less than 100 milliseconds, while the transition time between a dormant state and an active state should be less than 50 milliseconds. So followed by data rate and latency, we'll discuss about the performance requirements. The performance requirements for LTE is specified in terms of four things. First is spectrum efficiency, second is mobility, then coverage, then MBMS service. First we will discuss about spectrum efficiency. The average downlink user data rate and spectrum efficiency target is 3 to 4 times that of HSDPA 3G network. The high speed data packet access that is used in 3G network. So in LTE, the spectrum efficiency downlink user data rate and spectrum efficiency target is 3 to 4 times of the 3G network. The mobility, it is LTE is able to support mobility at different terminal speeds. Maximum performance at lower mobile speeds of 0 to 15 km per hour. When you coming to the coverage, good performance can be achieved or met up to 5 km. Whenever the cell is ranges up to 30 km, slight degradation of the user throughput which is tolerated 1. When the cell ranges up to 100 km, it should not be precluded by the specifications. MBMS service is multimedia broadcast and multi-service. In this, LTE should also provide enhanced support for this MBMS service when compared to the Ultra 3G operation. Next, it is radio resource management. The radio resource management requirements is to cover the various aspects. For example, to enhance the support for end-to-end QoS and efficient support for transmission of higher layers, such as can be support for load sharing, and it can be support for balancing and policy management and enforcement across different access technologies. The next thing is deployment scenario and coexistence with 3G. LTE shall support the following two deployment scenarios. First one is standalone deployment scenario, and next is integrating with existing UTRAN or GRAN deployment scenario. If you discuss about this standalone deployment scenario, where the operator deploys LTE either with no previous network deployed in the area or with no requirement for interworking with 2G and 3G networks. But if you are integrating with existing UTRAN and a GRAN deployment scenario, where the operator already has either a UTRAN that is 3G or a GRAN that is 2G network deployed, but it can be a full or partial coverage in the same geographical area. Followed by this, The next thing is flexibility of spectrum, and the flexibility of spectrum. While working on the flexibility of spectrum, the purpose is to share the wide spectrum. So we have to share the exist 3G technologies too. So these all are about the design principles of LTE and network architecture. The remaining things of introduction to LTE will be continued by the next section, it is session 2.